That last video about upper tails and the binomial hypothesis test started to get a bit long, so I've done the two-tailed tests in a second video. So we'll have the same situation, number of rainy days in April, same significance level, 5%, same H0, that we've got the correct model already. However, this time our alternative hypothesis is just going to be that the proportion of rainy days in April has changed. We are not stating whether it's increased or decreased, only that that probability is wrong. We're not sure at which end it's wrong. So what we would need to do, in this case, I'm just going to draw it as a curve for speed. I know it should be discrete and I've drawn it continuous, but it's just to get the idea across. We're now saying that we could be in either one of these regions here, and that together they should be 5%. So as close as I can, I'll split them to 2.5% either side. Okay? So I want to find the critical regions again, i.e. how many days would be too few rainy days and how many days would be too many rainy days, that I can be fairly sure that the number of rainy days in April has changed. What this 5% significance level means is that there's a 5% chance I have the right model and I accidentally reject it. As we said, there is a 2.5% chance I will fall into either one of these critical regions. So overall there's a 5% chance I will reject the wrong hypothesis. That's just a chance we have to take. If we reduce the significance level, it makes it harder to get a positive result, but we can be more certain of that positive result. So let's see how we do this. So first things first, just like before, we will guess at what our critical region is. So if we're expecting 9, a 2.5% chance of being too few rainy days, I would say it's probably going to be somewhere around the 3, 4, 5 region, somewhere like that. So those are numbers that are going to go into list mode in our calculator. Similarly, at the upper end, we would probably guess that it's going to be something around the area 13, 14, 15. Expecting 9, that's likely to mean too many rainy days. Okay, so let's do the lower tail first. You would have put each of these probabilities into your calculator, remembering that it's going to give you the probability that x is less than or equal to a given number. We need to write down the two which are closest to 2.5%. So if we look at those, that will be probability that x is less than or equal to 3, and the probability that x is less than or equal to 4. So less than or equal to 3 is 0.0093, and the probability that x is less than or equal to 4 is 0.0302. I don't need to bother with 5. This is less than 2.5%, that is more than 2.5%, so 5 will just be even more. Okay, like we said, usually we go for the one which is lower than the 2.5%. But occasionally the question may ask us to get each tail as close as possible to 2.5. That's what we're going to do in this case. So part of our critical region is x is less than or equal to 4. That's the easy bit. We now need to do the upper tail, and as we remember from the last video, that's slightly more complicated because we have to do this 1 minus business. So if we were to try 13 and 14, they're our two closest. Remember, the calculator only gives you less than or equal to, so we need to do 1 minus to figure out greater than or equal to. That's going to give us 1 minus 0.9599, and then the other one that's closest to 2.5% is x less than or equal to 14. Again, I don't need to bother with 14 because when we write this one down, 1 minus 0.9831, that's greater than 2.5, that's less than 2.5, 15 would still be less than 2.5. So calculating each of these, that's going to give us 1, 0, 4, 0, 4. And this one's going to give us 9, 6, 1, 0. Okay, so again, going for the one which is closest to 2.5%, that is this one. So our critical region here, remember, we've done 1 minus probability that x is less than or equal to 14. So 14 is the first value that we've taken away. Therefore, probability that x is greater than or equal to 15 is what we're left with. Now I can state the other side of my critical region. That means that if we get 4 or fewer rainy days, or 15 or more rainy days next April, we can assume that the probability is not 0.3 anymore. It's changed. We won't be able to say whether it's got greater or whether it's got less. All we can say is that it's changed, and that's very important if you have to write a conclusion to your test. Okay, one final thing that we'll do, we'll look at the actual significance level that we used, because if you look at this, that was as close as we could get to 2.5, as was that. So if we actually want to look at the significance level we ended up using, we just add these two values together. So adding those gives us 1, 7, 4, 4.71%. So we were aiming for a 5% significance level, but the closest we could get was 4.71%. If we get 4 rainy days or fewer, 15 rainy days or more, we will reject it, but there is a 4.71% chance that we will get one of those critical results, even if the probability is correct. And that's how we do hypothesis testing using the binomial distribution.